This is a quick review of metamorphic rocks. Okay, first of all, metamorphic or metamorphism just means to change. Okay, so it's a rock that is already existing, already made, already formed, that somehow there's a change within that rock. Okay, there's two key elements to metamorphic rocks, and it's heat and pressure. Okay, heat and pressure all the time. There's three different ways that we can metamorphose a rock. The first one is contact metamorphism. It's exactly what it sounds like. It is when a rock comes in direct contact with magma, okay, or lava. Causes a low grade, meaning just minor changes to the rock, okay, but it's in direct contact. And it's really important to think about both heat and pressure for all three of these different methods of metamorphism. So for contact, it's high heat, we're touching magma, but very low pressure, it can occur at the surface. Regional metamorphism is usually involved in mountain building, thinking about creating the Himalaya mountains. Okay, occurs a few kilometers below the surface. This would be considered very high-grade metamorphism, where you see a lot of zebra stripes, which we'll get to later, that foliation, and also a lot of faulting and folding occurring also. Okay, this is very high heat and high pressure. Okay, the heat comes from a lot of compression. Think about like squeezing a nail in a vise. The nail ends up heating up or hitting it with a hammer. And then obviously all of that pressure, also there's compressional forces there too. So high heat, high pressure. Burial metamorphism has low heat and high pressure. Okay, there's no magma present. There's some squeezing, there's some pressure, but not really a large change. And there's just pretty much high pressure. Think about just getting buried under many layers of sediment. That's what we're talking about. Again, agents of metamorphism are what causes that change to occur. The first and most important is the heat. Think about dissolving salt in water. What temperature water is the salt going to dissolve the quickest? It's going to be warm water, high heat. So heat kind of drives chemical reaction to occur faster and causes the recrystallization of minerals sometimes. Pressure, okay, is the second most important. That's the top two, heat and pressure. Increases with depths. It causes minerals to flatten and elongate, and it increases their density. Okay. A third agent that we need to talk about is a reaction, a solution, or pretty much just hydrothermal solutions. They can dissolve out minerals and take them away. So when we dissolve out minerals, we're subtracting that mineral from the composition of the already formed rock, leaving it with a different composition. Since we caused a change, that is a metamorphism, so it's a type of metamorphic rock. The classification we have in metamorphic rock can be foliated or non-foliated. The big difference here is that foliated rocks usually are rocks that begin with more minerals present, a variety of minerals. There's quartz and feldspar and hornblende and a bunch of different types of minerals. Okay, so under heat and pressure, those minerals can migrate, they collect together, they cause color bands, that zebra stripe. Non-foliated minerals usually are made out of one type of mineral. Okay, so you don't get that separation. That would be non-foliated. Okay, the rock names for metamorphic rocks change due to the intensity of the metamorphism. So highest grade, gneiss, to lowest grade, slate. If we look at a view of how this could potentially happen in a mountain range, right in the middle where you might have, let's say, a tectonic collision mountain building. Okay, highest grade would be gneiss, then branching out from there to the sides, schist, phyllite, and slate, as we decrease the strength of the metamorphism. If you have questions, please make sure to ask.